Alright nerds, so let's have a look at free body diagrams. Now, by the end of this, what we want to be able to do is we want to understand how a free body diagram shows us the forces, as well as how to draw them. So we want to know how to draw them, how to interpret them. What we want to be able to do is, if we give you something that shows some forces acting on an object, you want to be able to represent them diagrammatically by the end. Now, this is our vocabulary. If we can just get you to pause the video, write this down, and that way you've got it to refer back to as we move on through the lesson. So, a free body diagram, right? There are several steps to it. First, you want to identify the object with which we're drawing the diagram for. In this case here, we're going to look at this car. We want to identify all the forces acting directly on the object and the object exerting them. Okay, so for example, here we have weight, and that's caused by gravity pulling down. We have the contact force, when that is coming from the ground pushing up against the car. We have friction, which is the ground pushing against the car as it moves forward. We have air resistance, again pushing against the car as it moves forward. And we have a forward driving force, which is from within the car. It's an internal force. So we draw a dot or a box. We can draw a box to represent the object of interest. And we draw a vector, which is a line that has a very specific size as well as direction. So we draw a vector to represent each force. For example, here is our dot. Now again, as we said, this could be a box. Sometimes that's easier, and it depends on you, basically. There are some situations where you use one or the other, but in the high school level, they're fairly interchangeable. So the first thing we draw is we draw our force going down, weight or gravity. Then we draw our next force going up, which is our contact force, which is the ground pushing back against weight. And you'll notice that those two lines are the same size. So then we'll have all the forces going in this direction. We have the air resistance and friction. And you see, since they're both pushing in the exact same direction, we actually draw them one extending from the next. But it is clear where one force ends and one force begins. So we see that these forces, which are like number quantities, they're additional, they add. And here we see the driving force going the opposite direction. This is the engine pushing the car in the other direction. So that's our free body diagram. It's as simple as that. But we can use these numbers, these forces, these diagrams, to work out what the overall force on an object is going to be. For example, again, we can call this the net force. So the forces, we add them together. Remember, if you've got two going in opposite directions, they subtract from the other one. So here we have this force and the down force adding each other, and you'll see that they're the same size, so they'll cancel out. And then we have a force going in this direction and a force going in that direction, and the force going this direction, which is forward for the car, is actually larger, so it's a longer arrow. And what this means is we have a force in this direction. That's a numerical quantity. We don't have the number. We don't know what the number is in newtons. So the car will experience motion in this direction with the driving force. So let's have a look at two. Okay, we've got pusheen cat and we've got a wagon. Both of these are fairly common examples. Pusheen, not so much, but something sitting on a seesaw is. So this is our free body diagram. We've drawn We've drawn a box. We have the floor pushing up. That's 40 newtons up. Pushing down 40 newtons. Remember, newton is the unit for force. And because those two cancel each other out, that means that the wagon doesn't either fly up into the air or sink down. Those are balanced forces. We have a large force pushing in this direction, and you'll see that again, we draw it coming away, and it's 80 newtons. And we have a small force pushing in this direction, so we show it going in this direction, as it is, but again, pushing away from the object, of 40 newtons. Now, if we add all of those forces together, we get a 40 newton force as our net force going in this direction. So let's have a look at pusheen cat. Pusheen cat's a bit more complex because the force is being pushed out here, but the free body is in the center here. It's the fulcrum. So, and what a fulcrum is a point that a lever turns about. So these are now what we call opposing forces, because over here the downward force wants to push down, and this force wants to push down, but you'll see that this will cause it to turn in this direction, and this will cause it to turn in this direction, so they're opposing forces. And given that they're opposing forces, they balance each other out. Okay, so I hope that made a lot of sense. And if it didn't, put any questions you have in the comments below and we'll get back to you as quick as we can. Thanks for watching and we'll see you next time. Bye now.